All right, let's get back at it as we continue learning how to graph, this time as we start learning about how we use intercepts to graph. So we'll talk about the x and the y-intercept and how it's helpful as we uh, find ways to graph and find it might be easier to graph in that manner. So we know that we need at least 2 points to make a line. When we've been making our tables, we've had 5 or 3. Sometimes when you make the table, it makes sense to have more than 2 points, even though only 2 are needed for a line, because if your table is incorrect, if you messed up on one of the values, you'll find out that um, if you don't have a line, you messed up somewhere. So typically when you make a table, you choose more than that. But if we only need 2 points, how do we find those 2 convenient points? Well, I have 2 convenient points on the intercepts. Those are easy to find because I can see where the line crosses the y-axis or the x-axis. This would be known as the y-intercept because it intercepts or it crosses the y-axis, and then this point would be known as the x-intercept. Something special about that point, let's list its coordinate. It's 0, 8 for the y-intercept. The x-intercept is 4, 0. And you notice something special about those points. They both contain a 0. We'll talk about its significance as we go along, but we know that 4 times 4 is 16. 2 times 0 is 0, so 16 plus 0 is 16. It's a solution. And for our y-intercept, 0 times 4 is 0. 2 times 8 is 16. 16 equals 16. So that gives us another point that's convenient to find. If we have 0 of x, we can find out how many of y we need to make this true. Or we find 0 of y, how many of x do we need? Okay, so that'll be important as we start going through here. And keep in mind, this is a standard form equation. Remember, ax plus by equals c is standard form. Remember, standard form is when x and y are in the same, those terms are on the same side of the equation, with the constant term on the other side. So let's take a look at some examples of different graphs that we can make. Let's just practice, first of all, by identifying the intercepts on the graph. So our x-intercept would be negative 1, 2, 3, 4, 5. So negative 5, 0 would be our coordinates. So negative 5 and 0 for our x-intercept. And our y-intercept, where's across the y-axis? Right here. 1, 2, 3, 4, 5, 6. So 0, 6 would be the coordinates for that one. Okay. Next, we've got an equation, 5x minus 3y equals 15. Here are the coordinates for those intercepts, 0, negative 5, and 3, 0. And if we can find those points, we graph the line through it. Okay, so these match up with the table with the x and the y-intercept. We'll talk about how we get those in just a moment. But here's another example for the equation 2x plus 3y equals 12. My y-intercept is 0, 4. My x-intercept is 6, 0. Maybe you're starting to see a connection with how I can get these points. How can I find 0, 4? And how can I find this point of 6, 0? We're noticing every time is that we've got a 0 either the x or the y. And maybe you're seeing a connection here with the equation with how we get that point. Okay, so let's take a look at this one now. 5x minus 2y equals 15. 0, negative 7.5. 7. And 3, 0 are my two intercepts. Whoops. Curve that line a little much. Should probably get my ruler out and make a straight line next time. I'll try that right now. Anyway, as I'm doing that, you might want to take a look at those points and figure out, well, how am I able to get those points? Okay, where do these points, where's the connection with these points and this equation there? y3, 0 with my x and my y coordinate. y 0, negative 7.5. What's the connection between that and my equation over here? 0, negative 7.5 when I plug those in. Or 3 for x, 0 for y. Okay. So taking a look at these, how do we get our table of values? Maybe you're starting to see the connection. And once again, 2x minus y equals 6, 4, 5, 6, and 3, 0. Those are my points. Are you seeing the connection with how we get those points? Okay, so if you haven't figured it out already, I'll try to explain it to you. What we have when we're trying to find the y-intercept. Remember, okay, if we're trying to find that y-intercept, x is 0. If we look back at all these examples of the y-intercept, what's true about all of them? They're all on this line, which means they didn't move left or right at all. Their x value was 0. So x is 0. So how do we figure out what y would have to be? Well, we can kind of cover that up. Cover up the x because we don't need it. And that's not covering it up very well. Let's send this to front. There we go. So if I cover up the x, all I know is 2y equals 4. So if 2y equals 4, well, divide by 2, y would have to be 2. So that would mean when x is 0, y is 2. There's my ordered pair, 0, 2. The y-intercept of 2. Then, if y is 0, so substitute y for 0, well, 2 times y is nothing. X is 4. So if x is 4 and y was nothing, there's another ordered pair, 4, 0. And then once we have those intercepts plotted, we can connect the dots, because that will give us all of the points on the equation just from those 2 points, the y-intercept and the x-intercept. Okay, so why don't you try the example below, see if you can figure out the intercepts in that equation. Pause the video and start up again when you're ready. Okay, so in this equation, negative 3x plus 5y equals negative 15. Think if I want to find the y-intercept, I know it's not moving left or right, so the x value is going to be 0, so I can just eliminate that value. Say 5y equals negative 15, which would mean y would have to be negative 3. So x was 0, y is negative 3. Always think of that ordered pair that it results with. And then if we want to find the x-intercept, we remember it doesn't go up or down at all. So the y has to be 0. So we can eliminate y from the equation. Negative 3x equals negative 15. Divided by negative 3x is 5. So x is 5. The y that corresponds with it is 0. That gives us our x-intercept. Okay, so try this one. 2y plus 5x equals 10. Think, if I want to find my y-intercept, I need to put 0 in for x. And if I put 0 in for x, it kind of eliminates what I have here, because 5 times 0 is 0, so 2y is 10. Divide by 2. Y is 5. So x 0, y 5. That means my y-intercept is at 0, 5. And then we can do the same thing. And then if we want to find our x-intercept, we just remember that the y is 0 because it's not moving up or down from this line. So in that case, we know the y is nothing because 2 times 0 is nothing. So 5x equals 10 divided by 5. X has to be 2. So x is 2 when y is nothing. So 2, 0 is our x-intercept. And there we go. So that's the way we can find 2 points a little bit quicker than creating a table. So when we have standard form equations, that might be a way to graph the equations a little bit quicker. Same thing here. If we want to find the y-intercept, x is 0. So negative 5y equals 20 divided by negative 5. Y would be 4. So our y-intercept is 0, 4. And then if we wanted to find the x-intercept, I would know that the y is 0. So we could eliminate that part. 4x is 20 divided by 4. X would be 5. So x is 5 when y is 0. So if you're working through that one, you just want to keep in mind, always look to the left of your term. You don't eliminate that negative sign there. All right, now what about when it's in function form? We'll get to know this as slope-intercept form in a little bit. But how do we find the intercepts there? Well, nothing changes really. We could still follow the same format. I want to find out when, well, if I want to find the y-intercept, I know x is 0. So if I put 0 in for x, it's nothing. Y is negative 2. Okay, so that is our y-intercept. To find the x-intercept, put 0 in for y. So in that case, we just do the same thing, and we can just solve our equation. So now we take our y value, put 0 in for y, so it's nothing over here. So nothing equal to x minus 2. Well, I don't know what x is equal to yet, so I have to add 2 to both sides of the equation. And 2 is equal to x. So 2, 0 is my point. Okay, so substituting 0 in for x or y will give us those points. And if you struggle with that, maybe you think of it a different way. Maybe you prefer to have it in standard form. Well, no one's going to stop you from changing it to standard form. So you got the x and the y on the same side. So I'm going to subtract x. So I can get x and y on the same side. So I have negative x and a positive y equal to negative 2. And then if you prefer to solve it that way, and you say, well, if x is 0, I got nothing here for x, y is negative 2. Or we have that equation, and we say, well, y is nothing. Negative x is negative 2. Therefore, divided by a negative 1, x is 2. So notice we get the same values either way. Just go with the method that you are more comfortable with. So why don't you try that next example, pause the video, and see if you get the correct intercept. Okay, so just recall that you need to plug in 0 for x to find the y-intercept. And if I do that, I get negative 2, or plug 0 in for y. And then we need to solve for x. So in that case, we'd have 0 equal to negative 2 minus 8x. In order to get x by itself, I need to add 2. And then I have 2 equals negative 8x. And then divide by negative 8. Therefore, we get negative 1/4. The other way, remember, is we could switch it into standard form. Okay, so add 8x to both sides. Y plus 8x, or 8x plus y, equals negative 2. Then we cover up and solve. So if we say this x is nothing, y equals negative 2. Or if we wanted to find, with y being nothing, to find the x-intercept, 8x equals negative 2. Therefore, x equals negative 2/8 or negative 1/4. Plot those points, and there's a graph of all the solutions. All right, so we'll tackle word problems as we do our practice, but you just want to keep in mind that if it's in standard form, we can find 2 points to graph our equation by finding the intercepts. And if it's not in standard form, we can find those intercepts the same way by plugging in 0 for x to find the y-intercept, plugging in 0 for y to find the x-intercept, or we can switch that into standard form, whichever one we're more comfortable with.